Assalamualaikum and hi. Today we would like to present about thermodynamics 4, which is heat pump. The name of group members are Li Yitling, Muhammad Azman bin Cik Hamid, and Isham Aidi bin Zakaria. There are four types of objective for this experiment, which are to demonstrate the principle of heat transfer and exchanger. Second one is to demonstrate the principles of refrigeration cycle, to demonstrate the principle of a heat cycle, and to use the refrigeration data sheet and pH chart. As you can see, these are the apparatus arrangement for this experiment. The left one is from lab manual and the right one is from the real arrangement. The procedures for part A is the main water supply was turned on, and by a process of trial and error, set the evaporator and condenser water flow rates. All the thermometers are placed in the proper points as in the schematic diagram shown in figure 1. The measuring cylinder and stopwatch are used to measure the condenser and evaporator water mass flow rates for 1 minute. The condenser and evaporator inlet temperature Tc and Te are measured, and the initial reading of thermometers and pressures was recorded. Compressor was switched on, and step 4 was repeated every 5 minutes until the pressure P2 and 12 bars gauge and all the data in table 1 was recorded. Procedures for part B. When the pressure P2 is about 12 bars, the condenser and evaporator water flow rate was increased. Measurement was repeated as in steps 3 and steps 4 in part A for every 5 minutes. Step 1 once or twice was repeated until the condenser water flow rate is too high. The state of the refrigerant was observed and explained inside the viewing glasses A and B. That's all from me. I would like to pass the presentation to the next group members.
Hello everyone, my name is Muhammad Azman and now I will continue for the data collection and calculation for this experiment. If you guys can see that on this experiment we take a lot of data which is TE which is temperature evaporate, TC temperature condenser, P1 pressure 1, pressure 2, temperature 1 which is T1, T2, T3 and T4. Okay. For the time you start from 0 minute until 35 minutes. Okay. That's for part A and we take it during the experiment. Now the data collection during experiment, we also take the mass condenser which is MC and mass evaporator ME, uh, which is MC is 756.16 meter kilogram per second, while the mass evaporator ME equal to 539.89 meter kilogram per second. And also on the experiment, we took the uncertainty before the experiment started, which is for the for the mass, temperature, and pressure. And the observation also we took for the glass A, which is the in the liquid phase, and glass B in liquid vapor phase. For the observation and data collection, we take during the experiment. And for data collection for part B, we also take the same thing, which is mass, MC, ME, TE, TC, and so go and go on. And so go on. And but we take extra data, which is for volume condenser VC in millimeter and also volume evaporator VA. And then the data analysis for the part A, we take the average of heat transfer in evaporator. We use the formula QL equal to ME times CW delta TE. You guys can see this is the answer and the average for QL. And for the part A also, we take the average of heat transfer in condenser. We use the same equation but replace the CE with CW. So you can see over here, and this is the average of QH. And the data analysis for part A also, we took the average of COP in heat pump. We use the formula of COP equal to heating effect over power consumed. And this is the value of COP for the each time, and this is the average. And the data analysis for part B, we calculate the pressure absolute by plus the pressure on gauge plus the atmosphere's pressure, which is 1 times 10 to power dot of 5. So this is the answer for P1 and for P2. And for the part B, we sketch the graph analysis for the pressure interface diagram. So you guys can see over here. Same goes to this one, this one, this one, and this one. Okay, for the graph analysis, this is what the data that I take out from the graph, which is when you see, you guys can see for MC1, MC2, MC3, MC4, MC5. The H1 is constant. H2 for the MC1 is 420. For the others is constant. Same for H3 and also H4. Okay, so we the graph from the graph analysis, we'll calculate the QL using the formula, and WE using formula QH and COP. So this is the answer and the calculation procedure. So the average of WE, you guys can see over here, is 287.19 kilowatt.
My name is Liet Ling. Now I will present the discussion of T4. For the definition of heat pump is a refrigeration machine that uses electric to transfer heat. It absorbs heat from a cold space to a thermal reservoir, the warmer space. Include a condenser, a compressor, an expansion valve, and an evaporator. Then for the discussion based on data analysis, this is the symbol for the quantity we calculate and measure in the experiment. For your information, TC is higher than TE, T1 higher than T4, T2 higher than T3. And for part 1, error occur at time equal 5 minutes. T1 increases dramatically due to unstable flow rate of water. When time equals 30 and 45 minutes, T4 increases because the human error, parallax error. For the part A, error will occur at time equal 5 minutes. T1 increased dramatically due to unstable flow rate of water. When time equal 30 and 45 minutes, T4 increased because the human error, parallax error. When time increased, TE decreased and TC increased. The temperature of evaporator decreased as pressure decreased and reached constant at 3.5 bar. Temperature of condenser increased when pressure increased and reached maximum at 12 bar. These all are founded from the graph. And for the bottom one, the temperature, T1 is constant and decreased, and T2 decreased slowly. T3 increased, T4 also increased. For part B, when the time increased, volume of condenser and the mass of condenser increased, but at T equal 20 and 25 minutes, we see decrease due to the decreasing flow rate of water. Then, for VE and ME increased, but at T equal 10 minutes. This is also because of our error. For P1 and P2 is constant, but P2 decreased slowly due to effect of environment. As the rate of flow of water repeated once or twice in step 1 part B, the temperature in both buckets is affected by temperature of water pipe and the environment. For the error and precaution, the first error is the water flow rate is not maintained. We should fix the flow rate below the level label and ensure the coal is fully immersed in water. Then for the second one, parallax error, where the thermometer is set in slide and the observer eyes is not parallel to the scale. We can change the setting of the thermometer or lower down our body to see the scale clearly. Next, the human error when we record data every 5 minutes. We need to repeat the experiment to get the average value. The fourth one, limitation of the measuring apparatus. When we measure the volume and mass of water, the measuring cylinder is left with water drop, which will increase the percentage of error in our data collected. And the last one, the environment effect. We need to do the experiment in a room, close the fan to decrease the effect of wind. And these are the reference we use. Thank you, and this is the end of our presentation. Thanks for your attention.